First thing we want to do whenever we're testing a power supply, what we're going to do today is test a ATX power supply. First thing we want to do is make sure that the power coming out of the wall outlet is correct. So to do that, we're going to test the alternating current, AC. We can test that at the plug, and make sure you guys can see this. The fat plug, the larger plug on the left-hand side, if you're looking at it where the two flat prongs are on the top and the D shape is on the bottom, the one on the left-hand side is what's called your neutral. So you plug one of your leads in there, plug your other lead in. On the skinnier side, we've got 117.3 volts AC, right? Now, whenever you test this, this is the neutral, this is the hot. So left side is the neutral, right side is the hot. The bottom, the D shape on the bottom is your ground. And it is, as the name implies, goes directly to ground. What I'm doing now is I'm doing what's called a test for what we call dirty power, where we have power bleeding over from the neutral to the ground. We're getting 0.6 volts. Now, right now we're not testing an outlet, we're actually testing a power bar. So the power bar could be bad and just leaking power over. Electronics do not like to have anything on the neutral. So if you start getting a lot of voltage on the neutral, and I've actually seen in some cases where we had a bad transformer and the transformer was leaking power onto the neutral, we were getting up to 6 volts on the neutral side. The neutral side should be just completely dead. So I'm testing neutral to hot. We have 117 volts AC. So whenever you test that, test the outlet, make sure the outlet's good. And you think you may have a problem with your power supply. You want to test the power supply, well, you can do the same thing with your cord, right? Because you could have a bad cord as well. So if you're looking at the cord, the way you would plug it into the wall, this will be your neutral side. This will be your hot. So I plug that in. I've got 117.2 volts. I'm going to take the cord, I'm going to move it around, and if that voltage changed to 117.1.2, if it went to 110, 109, 123, something like that, then I would know that I have a problem with this cord. It's called a short. So it would be getting voltage, then stop. The voltage would drop and come back up. So right now we're getting 117. It's varying some, but that's varying some on this end where I'm actually moving the contacts around. So volts AC is alternating current. So I'm going to unplug both of those. Turn this off for now. So what I've done is I've verified that the power coming out of the wall, coming across my cord, going into the power supply is good. So your power supply needs at least 110 volts AC to actually do what it needs to do. So what this is a transformer. So we're transforming AC power into DC power and converting it. Computers run on DC or direct current. Direct current is different from alternating current. Alternating current, as the name implies, like I told you guys yesterday, runs at 60 hertz, the US, and alternates between positive and negative. Whenever we switch over to direct current with the power supply has positive and a negative. So we want to be able to test that and make sure this is actually putting out the right amount of voltage. So this is what's called an unpowered test. So we're not actually testing a live machine. We're just testing the power supply to make sure it's actually putting out the way it's supposed to. So if we have an issue here, then we know that we're going to have an issue with the computer. So if you want to do a live test and have this plugged into the board and the computer turned on, you can plug into the back of the prongs here and see what your voltage is on the machine while it has a load on it. So right now it's not unloaded, it's just sitting here. So I'm going to plug this in. And if you guys can see on the back of the power supply, we have a switch. It says 115. You switch it over, it says 230, right? So in the United States, we run between 110 and 120 volts AC. Sometimes in the summertime it runs a little bit higher. That's not that big of a deal as long as it doesn't go too high. In Europe, pretty much everywhere else in the world, they run 230. So if you have a problem with the power supply in the United States and the machine won't come on, first thing is check the power button, make sure the power button's on. So the I there is on, the O is off. And next thing you want to check is if it has a switch in the back and the switch has been powered to 230. Switch over to 230. So if it's not getting 230 volts, it just won't come on, right? So this needs to be set to 115. Some of the higher dollar power supplies, more expensive ones, they're auto switching. They will switch inside. They don't actually have a switch on the machine. So this is your ATX. This is a 20 and 4. So it has 20 pins, then it has an extra 4 pin. Some of the older power supplies didn't have that. They didn't have the extra 4 pins. They didn't need them. But as boards have gotten more power hungry, we're using higher wattage CPUs, higher wattage RAM, hard drives, multiple hard drives, GPUs, things of that nature. You have to actually have more power into the board. So what you're looking at is all the different colors here. Can anybody tell me what all these colors are? And what all the powers are for each color? Well, it has a voltage applied to it. So your red is actually 5 volt, your yellow is 12 volt, and your orange is 3.3 volts. Now, of course, all of this is direct current. All of this is DC power. So whenever we go to check this, we're going to have to switch our multimeter from AC back over to DC. If you don't, you won't get a reading at all. And then the black here is your ground. So this is your ground wire for the power supply. Your black is. So what we have to do whenever we're testing this is we have to plug our black wire in somewhere where we can get a ground, and we'll plug our red wire in, use it to actually test our voltage with. So if you guys see, the power supply is not actually on, and the reason it's not on is because it knows it's not plugged into a motherboard. So they have little plugs you can make to plug in here, and then it'll ground it, and the power supply will come on. But I always just use a paper clip. Now, this sounds kind of counterintuitive, taking a paper clip and plugging it into a power supply. But as long as you're plugging it into the right ports, you're fine. We're going to plug it into the green, which is the power good, and one of the blacks that goes to ground. So what we're doing is we're basically telling the power supply that it's grounded through the board. So I'm going to bend this in half. And then what I want to do is I want to bend both of these over to give me a connection that kind of stays out of my way. So I want to bend that a little bit. If you guys can see this, you have a green wire here, which is power good wire, and then all the blacks here along the side, these are all your ground wires. So you guys watch the fan, be able to see that come on. I'm going to plug one side into the green. Now be careful when you're doing this, and don't plug it into the wrong spot, and plug one side into the ground. Alright, now that's grounded, so I'm going to turn my power supply on. So now the power supply is producing power. Now we can go back and we can actually check to see how much power it's producing. So take the multimeter, and always use Fluke. I've used Fluke for years. They're really tough. That's one reason I like to use them. I'm going to take my black side. I've switched to DC. You see where we have the hertz here. Right? I was telling you guys yesterday what hertz were. Volts hertz. We have a wavy line. And here we turn to volts AC, or volts DC. We have a dotted line and a straight line. So that's positive and negative. So I'm going to take my black lead on my multimeter. I'm going to plug it into one of my Molex connectors, because this actually fits inside the Molex connector really easily. So I have 2 ground wires here in the center. Plug that into one of them. Slide that in. Now I have a connection that I can actually test all these voltages on. So usually what I do is I'll test one, then I'll set it to the side, test another one, set it to the side, back and forth. So if you didn't plug the black probe in, plug it into ground, you wouldn't actually have anything. right? You wouldn't be able to test anything. I can unplug this, and I can plug this into one of the reds, right? I'm not getting any kind of voltage. There's a yellow, no voltage. There's an orange, no voltage, and you guys can see that. I'm not getting anything. Now I could come up here and I could bridge this across like this, and this isn't going to hurt you. It's not going to shock you. As you can see, I'm getting 3.349 volts. Now I'm getting 5 volts. This makes it a little bit easier. You can just plug it into the Molex. Plug it into the Molex, you don't have to hold it. All you have to worry about then is the red probe and your power supply connectors. All right, so that's grounded now. I can go back and I can check all the voltages on my power supply. So it's all separated by color. Purple is your 5-volt standby. Your red is 5 volt. Orange is 3.3 volts. Blue is negative 12 volt. And then your yellow is 12 volt. So I should have, go ahead and separate these. I should have 5 volts, 12 volts, 3.3 volts, then I have another ground. So with power supplies, they have a top and bottom. So as long as it's not out of range more than 5%, it's good, right? So I'm going to check my 5 volt. It's 5.14. My 12 volt, the yellow is 12.52, and my orange is 3.34. So this part of the plug is good. It's putting out everything it should. Now, a lot of people say that you can just check any of the colors, and if you have the right voltage at that color, then you'll be fine, because there's a 12 volt rail, there's a 3.3 and a 5 volt rail, and you don't have to worry about checking anything else. But I always like to go through and check the entire plug to make sure that we don't have any breaks anywhere or shorts. So I should have, you guys can see this, should have 5 volt. I got 5.13, 5.13. I'm gonna come down and check my blue. My blue should be negative 12. Now, all of the rest of these have a plus or minus 5%. Your negative 12 volt is plus or minus 10%, so it may be a little bit low. It's showing 10.93, right? So what is 10% of 12 volt? 1.2. So if I had, if this voltage was negative 10.7 or below, or negative 10.8 or below, then it would be bad, because it's out of range. But this is negative 10.93, so it's at the bottom of the range, but it's still good. So that's your only negative that you're checking. My orange is 3.3. Orange over here, 3.3, 3.3. Make sure you don't touch these. 5.13, 5.13, 5.05. That's my standby, and 12.52. All right, so these have been tested to be good. Let's set these to the side. Make sure my paperclip doesn't come out. So now I can go back and check my Molex. The red is 5.13. Yellow is 12.52. Now this is a Berg connector, used mainly for floppies. Some add-on cards will use one of these for power. That's your ground. You're not going to get any voltage off your ground. Should have 12 volts here. 12.52. And then it's 5.13. Sure all you guys can see that. So these are all daisy chained together. You guys ever seen a daisy chain? Right? So if you check the very last one in the chain, and everything else is going to be good. We can go through and check these. You may have an issue where if it's an older power supply and it's been unplugged and plugged a lot, these little barrels in here will actually open up and they won't make good contact. But if you're checking for your voltage, they should be fine. Now you can always buy more of these. These actually plug in. Have little male and female adapters. You can change them out if something goes wrong with it. So that one checks good. I'm gonna set it to the side. So this one has two ground wires. It has two 12 volt. Check this one. It's 12.52, 12.52. So it's good. 8 pin. That's 4 12 volt connectors on it. And I always want to check all of these. And if you want to be really sure about it, you move the cable up and down to make sure it doesn't have any shorts in it. Alright, so that one's fine. So we've tested our 24 pin, our 20 plus 4, tested the 4 pin, 8 pin. We've tested this daisy chain of Molex and bird connectors. So now I'll check this last Molex. It should have 12 volt. It's 12.52. That's 5.13. Set that one to the side. Now we come to SATA. SATA actually has 3 different voltages on it. So SATA has 12 volt, 5 volt, and 3.3 volt. And it needs that depending on what type of device you have it plugged into. Some of the devices have motors in them, and the motors need a 12 volt power supply. So we can't check that running across here. And we probably could shove it in there, but you're more than likely going to break this connection. So you don't want to cross these pins either, because you could accidentally cross from a 5 volt to a ground and actually short the plug out. And if you did that, you have a possibility of damaging the power supply. So what I like to do with these is I'll just actually bend them back and check them from the back side. So I should have 3.3 volts here. I have 3.34. Should have 5 volts here. I have 5.13. I should have 12 volts here. I have 12.52. Right? So now we've checked every device or every plug on this power supply. Fan's running. Everything is within range. Our negative 12 volt is right at the bottom of the range, right? So it's plus or minus 10%. It was 10.9. If it goes below 10.8, then it's bad. It's considered out of range, and it's not supplying the proper amount of voltage. But an unloaded power supply, and it's all checking fine. Now, if you plug this into a computer and you turn the computer on and it runs for a little while and starts acting kind of wonky, you can go back in and check the back of these plugs to make sure that once it's actually loaded up and once it's actually producing power and it's having power drawn from it by motors running, CPU running, those kinds of things, if you can check to see if the voltage has started dropping, and then you can check your ranges to make sure that they're staying within the range.